confidence intervals. We're going to start out with an example here. So in a study of a sample, the mean observed in the sample is 100, the mean in the sample being x hat. The standard deviation observed in the sample S is 10, and the sample size in the sample N is 10,000. And so we're going to be trying to find a confidence interval here. And so a confidence interval is pretty much saying that given that this is a sample, what is a range that the true mean mu will be in the population? So it's 100 in a sample, but that doesn't mean it's going to be 100 in the population, right? So what is a range at which it's going to fall at? And so a 95% confidence interval, for example, would say that we're 95% confident that the true mean mu would be within a given range, given that the sample is 100, the sample mean is 100, the sample standard deviation is 10, and the sample size in it is 10,000 in this study. So let's move over to the formula here. The formula for finding a confidence interval is x hat, which is going to be our sample mean, plus or minus the confidence level value, or the z-score associated with that, multiplied by the sample standard deviation, which we know is 10, and then over the square root of the sample size, which is 10,000. And so this confidence level value, right, z, we're going to be using different values depending on how confident we want to be. So if we only want to be 90% confident, the value is going to be 1.645. If we want to be 95% confident, the value is going to be 1.96. And if we want to be 99% confident, the value is going to be 2.58. And so as you can see, the more confident we want to be, the bigger the range is going to be, right? Because the bigger a factor z is going to be in this equation. And more often than not, you're likely to use a 95% confidence interval, so we're going to use that here. Going down to the equation here, let's plug in some values. So once again, we're going to be plugging in the sample mean here of 100, plus the score that we're going to be using of 1.96, multiplied by the sample standard deviation over the sample size of 10,000. And I just want to say here that a sample size of 10,000 is large. That isn't always the case. It's hard to get a sample size that large, but because it's so large, it has a higher chance of being represented in the population. And so we'll see that here, that these stats are going to be pretty representative with our confidence interval. And so we're going to simplify this calculation here on the side. Square root of 10,000 is 100. 10 over 100 is 0.1. And so moving down here, confidence interval is going to be 100 plus or minus 1.96 multiplied by 0.1, or 100 plus or minus 0.196. And so to put all that together, for the confidence interval at 95% confidence is going to be 100 minus 0.196 at the low end, and then 100 plus 0.196 at the high end. And so what are we really seeing here, right? We know that the mean in the sample is 100. And so we want to find out what the true mean is in the population, right? That's the whole goal of this. But we don't know what it is 100% just from the sample. And so what we're saying here is that we can be 95% sure that given all of the given information, that the true mean lies between 99.804 and 100.196. And so this really means that the sample mean of 100 we're predicting is going to be pretty close to the actual mean. And one of the main reasons for that is because our sample size was so large, right, of 10,000. So let's try something else. Let's say our sample size is 100, right? What happens then? So here, instead of 10,000, we now have 100 instead. Square root of 100 is just 10. And now it's plus or minus 1.96. Now we're going to be going down to our true, or rather our new confidence interval of 98.04 and 101.96. So if we had only measured 100 people, right, instead of the 10,000, at a 95% confidence interval, it is now going to be between, we're sure that the true mean is going to be between 98.04 and 101.96. And so I urge you to play around with these values a bit and see how that changes. If n is even lower, this range is going to be even bigger, right? And we can tell because that's on the bottom of the equation. And so just play around with a little bit and see which values, as you change them, affect how that affects the confidence interval. And yeah, thank you for watching.